Hello Year 8s. I've been very much looking forward to this lesson where we put our plans from our experiment last lesson into reality. So to start off, in your Introduction to Science booklets, I want you to find the Designing an Experiment page in your book that you filled in last lesson, and I want you to have a reflection on your method that you wrote. I want you to think about the things that we said a good method has. In essence, if I pick up your method and I followed the instructions step by step, would the experiment work? And would you have given me enough detail so that I can copy the experiment or do the experiment and get exactly the same results as you? Now that is a good experiment. Now, remember the analogy I gave you? If Jamie Oliver gave me really good instructions, I would be able to cook just like him. So what I want you to do is reflect on your method and see if there's anything you can do to improve it. And I'm going to give you 5 minutes to do that. And then if you've got another color pen or a pencil, we're going to highlight some key points. So pause the video and then start when you are ready. Okay, so I hope you're really challenging yourself to do even better and be even more detailed in your method. So if I'm looking through your method, these are the kind of things that I would be looking for. So let's just have a little bit of a check here. So have you, in your method, have you described the independent variable in detail? So have you said we're going to use 3 blue, 3 red, 3 green, 3 orange, 3 yellow and brown M&Ms? Because if I use different colors, I'm going to get different results. If you've done that, can you put a little tick in pencil and put an I in a circle for independent variable in that section of your method? Okay, now looking at your method, have you discussed the dependent variable in detail? So have you said, I'm going to time how long it takes for each color to reach the center of the X from when I add the water? That way, the person doing the experiment knows exactly when to start. So they start the stopwatch when the water is added, and they stop the stopwatch or they record the time when it reaches that X. Okay. Right, and then in your method, have you mentioned the control variables? So have you said that you need to use chocolate M&Ms? Because maybe peanut M&Ms will not only cause allergies, but it could have different results. Have you mentioned the same volume of water? And it doesn't matter if you're guessing how much we use, but you state specifically how much water you want me to use. So if we say 30 mils, write in 30 mils, so I can do it exactly like you. You might have come up with other ones, like use the same size Petri dish. That's a good one. And another good one is the same temperature of the water, because the temperature of the water could speed it up or slow it down. Excellent if you put that point down. So perhaps you want to say use the water, warm water or water at 40 degrees Celsius. You can be as specific as you want to. And have you mentioned how you're going to make your experiment reliable? So the reason why I've chosen 3 of each color is because then we are tracking 3 at a time. We can then get an average, and if one of them is way out, so for example the person recording that result wasn't concentrating or couldn't get their stopwatch to work, then what we do is we add up the 2 good results and we divide by 2. But if we've got 3 good results, to work out the average, we add up those times and we divide by 3. Okay, so hopefully you've identified the D part, the C part, the control variables, and the R part, how have I made it reliable? Okay, now what I would like you to do is I would like you to think about in pairs, how would you design a table for your experiment? And you've got 2 minutes to sketch it out in rough, okay, and then we'll have a look and see how yours compares with mine. How did that go? Did you remember that lesson where we're talking about where we put the I and the D in the table? Okay, right, so this is what I came up with. Right, now there could be variations on this one, and they could be absolutely right, but the principle needs to be the same. So we start off with the I, the independent variable, and the independent variable is the color of the M&M. So I've clearly stated it in the first column of my table, and I've also listed the number of, or the colors that I'm using. Just note, because this is going to be useful in a moment, the very front row right by my desk, you're going to focus on the red M&Ms. The first bench is going to focus on the orange M&Ms, the first 4 in the row, and the next 4 on that front bench, you are going to focus on the green M&Ms. Then, if you're on row 2, you're going to collect results for the yellow ones. Row 3, you're going to focus on the brown M&Ms, and row 4, you are going to focus on the blue M&Ms. So you've got a huge responsibility to make sure the whole class gets accurate results. Okay, right, so what you're going to do is you're going to time, this is the dependent variable, you're going to record the time it takes for the die to reach the middle of the X. And the units, really important to state, the units I'm going to measure it in is seconds. So if it goes into 1 minute, you've got to go 60 plus how many seconds. Now what we're going to do is we're repeating this 3 times because we've got 3 of each color, and then in this final column you're going to plot the average time in seconds for the die to reach the X. Okay, so you're going to need your calculators once we get to that point to calculate the average, and then you are going to plot that in a graph in the way that I've shown you how to do. Okay, so what I would like you to do with a ruler, copy the table, and when you are ready, we'll start the next video looking at the experiment.